So we are live. We should be live at least. Today I just wanted to look into Go language. There's a really good website, Go By Example. Go By Example is a hands-on introduction to Go using annotated example programs. Check out the first example. Unless stated otherwise, examples here are assumed latest major release Go, and you may use a new language features. All right, so Go, obviously I will not be looking at control flow, arrays, slices, maps, uh, functions, multiple return value, periodic functions. All of this is very basic, and today I want to look at different stuff. Let's start with closures. Um, all right, what's a closure? Um, Go supports anonymous functions, which can form closures. Oh, right, it hurts my eyes. Go supports anonymous functions, which can form closures. All right. Anonymous functions are useful when you want to define a function inline without having to name it. All right, I get why you would do that. I get it. Return function. All right. This function int returns another function int sec. It returns a function. This is so cool in Golang that you can return functions. Returns another function which we defined anonymously in the body of int sec. The return function closes over the variable I to form a closure. I don't really get this, but all right. We call int sec, next int, next int, next int, next int, int sec, next int. So 1, 2, 3, 1. All right, this is so cool. Closes over the variable I. What does this mean? Closes the return function closes over I plus plus. So I is defined in int sec. And when we do this, next int. What's next int? What is next int here? Right, this is a variable, but what is this? Right, we call int sec assigning the result. We call int sec assigning the result a function to a next int. Oh, so this variable is basically a function, right? All right. Then you can call this function again. Then you can call this function again, and again, and again, again. The function value captures its own I value. This function value captures its own I value, which will be updated each time we call next int. See the effects of the closure by calling next int a new times to confirm that this state is unique. Is this function, when it is called here, is it going to be generated again? Closure closes over the variable I, the return function, the body of int sec. The returned function, this function closes over the variable. I don't get any of this. I don't get any of this, to be honest. Oh, in programming languages, a closure, also lexical closure, or let me also just I need a text editor. New one. Closures. Text. No, just Golang one. Text. All right. Programming languages, a closure, also lexical closure or a function closure, is a technique for implementing lexically scoped name binding in a language with first-class functions. A first-class functions, if it treats function as first-class citizens, this means the language supports passing functions as arguments to other functions. First-class functions. Does C++ have this stuff? Operationally, a closure is a record storing a function together with an environment. The environment is a mapping associating each free variable. What's a free variable? In mathematics and other disciplines in formal languages, a variable may be said to be either free or bound. Some older books use term free real variable or apparent variable of the function, variables that are used locally but defined in an enclosing scope of the function. Free variable of the function is a function that is locally used locally but defined in an enclosing scope. Enclosing means right, enclosing, just surrounding, envelope, enclose a copy of, place something in an envelope, enclosing, entire estate was enclosing with walls. All right, surrounding, enclosing. Unlike a plain function, a closure allows the function to access those captured variables through the closure's copies of the values of the references, even when the function is invoked outside their scope. PAL programming language. Oh, that's a so I is defined here, and then a function is returned, right? It says I++, so now I here became 1, and I is returned, so 1 is returned. The next oh, this is a different variable and this is a different variable and new ints. All right, so closure, what could be the purpose of this? I get how this works. I get how it works. Like you can call this function and like this enclosing variables will be saved, but I don't get where would this be practically useful. I don't see why would this be a practically useful thing in programming. In SAC, to confirm that the state is unique to that particular function, create and test a new one. All right, so let's just read it again. The function returns another function, which we defined anonymously in the body of insec. The return function closes over the variable I to form a closure. I don't particularly get I'm gonna ask ChatGPT. Uh, what does closes over mean? I don't get it. Means that the return function captures and keeps access to variables from its surrounding scope, even after that scope has finished executing. So this scope has finished executing um, in here, at here, but we still close over, close over, close over. Surround something, surrounding. Hmm. Right, the body. Function value captures its own I value. It's like an object. Um, Right. Isolating data. The first use case we're going to discuss is isolating data. We covered briefly. Shoot. It's okay. Uh, we covered this briefly in the last article lesson, so we won't spend too much time on this example. Let's say you want to create a function that access to data that persists even after the function exits. For example, you want to count how many times the function has been called. Oh, that's an important thing, I guess. How many times the function has been called. Or you want to create a Fibonacci number generator, but you don't want anyone else to have access to that data so that they can't accidentally change it. You can use closures to achieve this. Make Fibonacci generator. Okay, F1, 0, 1. We have F2, F1, F2. Alright, this looks good, I think. But make Fibonacci generator and then generate. Yeah, this stuff would get updated. This makes a lot of sense now, but sure, you could use a custom type to create something very similar. But if you wanted to work with multiple number generators, you would likely need to eventually declare an interface and accept that as an argument to other functions. Type generator interface next int g next to work with n. Do work for generator. With a closure, you can instead just require that a function is passed in as your argument. Since you really care about one of the methods in the generator interface anyway, do work function int. What's going on? To work with n. Middleware, wrapping functions and creating middleware. What the hell is middleware? Functions in Go are first-class citizens. Is that you can not only create anonymous functions dynamically, but you can also pass functions as parameters to a function. For example, when creating a web server, it is common to provide a function that processes web requests to a specific route. HTTP handle function, hello. Function hello, HTTP response writer, and request. A fancy term for reusable function that can run code before and after your code designed to handle your code designed. To verify if a user is logged in once, then apply it to all of your member-only pages. What? This has been very... This was really interesting. I did not get a middleware. Hmm. Um, like, all right, let's understand middleware. Go by example. Does this have a middleware? Generic struct embedding interfaces. Alright. Starts with closures. Middleware. Alright, let's just read this code. Wait. So far you've seen how to build a Go web server that routes requests to a different functions depending on the requested URL. I haven't really seen that, but what if you want to execute some code before and after every request? Regardless of the requested URL. For example, what if you wanted to log all requests made to your server, or allow all of your APIs to be callable cross-origin, or ensure that the current user has authenticated before calling the handler for a secure resource? Current user has authenticated before calling the handler for a secure resource. We can do all of these things easily and efficiently using a middleware handler. Where was handler called first? Go client sends a request to the HTTP server. Middleware handler goes to a MOOCs. What's the MOOCs here? Handler function. HTTP handler that wraps another HTTP handler. Another handler to do some pre and or post processing of the request. It's called middleware because it sits in the middle between the Go web server and the actual handler. What's the actual handler? Logging middleware. All right. To see how this works, let's build a simple web server with a logging middleware handler. Create a new directory inside your GoPath source directory and create a file within that directory named main.go. Create a new directory inside your GoPath source and create a file within that directory main.go. Just main.go. Why do you need to do this? GoPath source directory. But okay. Import fmt log net http os time. All right. Hello handler. Response writer. HTTP request. So we get the request and we get the response writer, HTTP response writer. I'll write the response a byte hello world. So you cast this into a byte array. Is this what Golang is doing? Current time handler, response writer, it's request current time, time now, format. All right, current time. This gets current time. Write. Byte fmt sprint f. The current time is da 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 da. Main os get environment address. What is that? Address. Service listening at address. Log fatal. Right. Handle mux. So there's new server mux. New serve mux. Serve mux can now map the URI patterns to the HTTP methods. That's interesting. Request. Multiplexing HTTP requests allows the usage of single connection per client, meaning that a single connection between the client and the web server can be used to serve all requests asynchronously, enabling the web server to use less resources to support more. Whoa, devil is in the detail. Multiplexing. Looking to the app side, application side, requests using multiple connections, and multiplexed in a single connection. Da 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 da. Whoa, what? Go. All right, serve mux is all you need. Go HTTP serve mux. Serve mux. In the field of Go web development, to achieve more efficient and flexible routing functions, many developers choose to introduce third-party libraries such as HTTP router, Golang mux. However, in Go version, to optimize serve mux in the standard library. This reduces developers' reliance on third-party routing libraries and has pattern matching ability. Has implemented a much anticipated proposal to enhance pattern matching ability to default HTTP service multiplexer. Multiplexer can only provide basic path matching functions, which are relatively limited. This has led to emergence of large number of third-party libraries to meet development needs for more powerful routing functions. The new multiplexer in Go will significantly narrow a functional gap with third-party libraries by introducing advanced matching capabilities. This article new multiplexer, providing examples of a REST server. And compare the performance of the new standard library MOOCs. Alright, basic usage, new MOOCs. New serve MOOCs. Alright, handle function, get path. Oh, got path. Tasks, task ID. Alright, so this just basically, this is a server. Experience scope can image notice two new features. Get is explicitly used as a part of a pattern. This means that the sender will now only respond to get requests for path, starting with path. Alright, this is cool. The second support ID. Alright, this is cool. So a MOOCs handle. So this is just a router. This is just a routing, right? Nothing fancy, as I understand. Handle func. Hello, hello. A function hello. Response writer. FMT print line W writer and hello. So functions are first-class citizens. For example, when creating a web server, it is common to provide a function that processes web requests in a specific route. So, okay, if we get a request like this, we need to listen and serve. We need to this function will be called when the server gets this request. And what this function does is prints a writer, print ln hello. I don't get, in this case, the function hello is passed to the handle func, and is called when that route is matched. Alright. While this code doesn't require closure, closures are incredibly helpful if we want to wrap our handlers with more logic. A perfect example for this is when we want to create a middleware to do work. Middleware is basically a for reusable function that can run code before and after your code designed to handle a request. In Go, there typically comes with closures, but in different programming languages in other ways. Using middleware is common when writing web applications, and they can be used for more than just timers, which you will see an example below. For instance, a middleware can be used to write code to verify if a user is logged in once, then apply it to all your member only, right? Code to verify user is logged in. All right, so we have a handle func thing which timed hello. What's timed? Well, hello is another function, timed is another function. It gets, as an argument, it gets, return. It returns this. With these arguments, returns this function with these arguments. Response writer and request. Response writer and request is like a hello. A timed hello function. Start time now. We do f. What's f, by the way? What's this? What is this? Right, start is okay, end is okay. V and R. f is some function, but I don't see what function that is. Notice that our timed function takes in function that could be used as a handler function. Oh, f is this, takes in a, f is argument to timed and returns a function of the same type, but the return function is different than the one past one past it. The closure being returned logs the current time. The closure being returned logs the current time and calls the original function. And finally logs the end time and prints the duration of the request. Whoa. Duration of the request, all while being agnostic to what it is actually happening inside of our handler function. Now, all we need to do to time our handlers is to wrap them in timed handler. Whoa, timed handler. Pass function to them. Right, this function, I get it. We call some handler function and then we print whatever this was. This will print how much time the hello function took. But why do we need this? Simpler timer middleware. Timer middleware. I'm just gonna ask ChatGPT. I'm gonna do the bad thing. All right. Consider this code. Laconically tell me what it does. It's a timer. Handles hello by responding with hello and logging the request duration. Meaning it measures the time between just before performance, detects slow handlers, debug latency issues, performance regressions, to measure performance. All right. You know, an interesting thing would be to see an authorization middleware. But accessing data that typically isn't available. All right, disclosure. There is nothing odd about this code. It's just a function that times how long this took. There's nothing. All right, we have a function, hello, and we want to know how much time this function takes. Just create a new function and give it that. And it will time. This is so cool. This is just hello. Like this returns a function, which is basically a function that just calls hello. So hello will be called, so this will happen. So when like this whole blue thing is just this thing. It's interesting. Like, why is closure needed here? Um, why is closure needed here? This is um, like, can timing be done without closures? And required. You can time functions without them by calling timer around each call directly. Alright. Hello timer, time now, hello timed. Yeah, you can just do this. Why would you? Ugh. I don't think this is important, to be honest. Yeah, you just define the function directly. Like how many times a function was called, like how to count how many times. All right. You know what closures are? Recursion, range over built-in types. This is gonna be easy. Pointers are gonna be easy. Strings and runes. I don't care about strings and runes. Structs, methods, interfaces, enums, struct embedding, generics, range over iterators, errors, custom errors, go routines. You know, this stuff will probably be understandable. Now, I just want to look into the go routines. Oof, this is gonna be a big thing. Suppose we have a function called fs. Here is how we'd call that in the usual way, running it synchronously. All right, we have this and we just call it direct synchronously. To invoke this function in a go routine, we use go, right? Go do this. This is gonna directly do it. Go routine. Go func msg print line going. What? What? What's msg? Msg is a string, and it just go, and then going. Time sleep, time done, time second. All right. It's just gonna sleep for a sec and then print done. And the output will be like direct 0, 1, 2. Well, this is very understandable. I think this is very understandable. Why is it called from? Oh, it's from direct call, go routine. This is from go routine. 0, going, What's going? Oh, two of these function will this and this will go at the will go together, right? Uh, going, just print going. Um, does it have to be go and some function? Yeah, that's probably it. Go, sleep, go routine 1, go routine 2, and done. Alright, this is understandable. Our two function calls are running as async. You can also start a go routine for an anonymous function. To invoke this function in a go routine, use go fs. Two function calls are running async in separate go routines now. Wait for them to finish. For a more robust approach, use a wait group. Alright, wait group is a different thing. When we run this program, we see the output of the blocking call first, then the output of the two go routines. The go routines output may be interleaved because the go routines are being run concurrently by the go runtime. When we run this program, we see the output of the blocking call first, then the output of two go routines. Two go routines output may be interleaved because go routines are being concurrently by go runtime. Next, we'll look at complements to Go routines in a concurrent Go programs channels. Channels are the pipes that connect concurrent Go routines. You can send values into channels from one Go routine and receive those into another Go routine. Alright, create a new channel with make chan file type. Channels are typed by the values they convey. Send a value into channel using the channel this is send. Here we send ping to the messages channel. Alright, this is the channel. Channel is called messages, go func, messages ping, messages when we run program, the ping messages successfully passed from one go routine to another. Message go func messages ping msg, and then you can read. Will by default sends and receives block until both. By default sends and receives block until both the sender and receiver are ready. This property allowed us to wait at the end of our program for the ping message. Channel buffering. Unbuffered. By default, channels are unbuffered, meaning that they will only accept send. writing files, writing line filters, file paths, directories, temporary files, testing and benchmarking, command line arguments, flags, subcommands, logging. Let's see logging. Let's check out logging. The Go standard library provides a straightforward tools for outputting logs from Go programs with the log package for freeform output and logs log packages for structured output. Simply invoking functions like println from the log packages use the standard logger, which is already pre-configured for reasonable logging output to std_err. Additional methods like fatal or panic will exit the program after logging. Loggers can be configured with flags to set their output format. By default, the standard logger has the log set, and these are collected in. We can change its flags to emit time from microsecond accuracy, for example. Emitting file name and line from the. It may be useful to create a custom logger and pass it around. Alright, just log println, log set flags, microseconds with micro, file line, new std out line. Alright. Logging. So go on logging, standard logger with micro, logging, time, my JSON handler, new slog handler std_err nil. All right, exit. Busted exit 3. Defer exit signals. Performance and the Unix signals. Unix signals. Over Wikipedia page. We might want the server to gracefully shut down when it receives SIGTERN or a command line to stop proceeding. Go channels. This seems like Linux stuff. Executing programs, processes, like spawning external processes. You can spawn an external process, but exec command grep hello. Output and other methods of command. Exec os.exec. In Windows, Golang exec os exec. Note that this assumes a Unix system. The examples in the package assume a Unix system. They may not run on Windows as they do not run in Go. Playground is Golang. Does Golang OS library work on Windows? Can be installed on Golang. Right. Packages, OS package, Windows. All right. This is a pretty good resource, I guess. I guess Golang is good for writing concurrent programs, um, and so on. I really want to look at one book, which I am not gonna mention, but I'm gonna look at it. System level IO. Like all of this stuff can be done by other languages, right? C++, currency. Concurrency in C++. Concurrency refers to process multiple tasks or threads at the same time. It is used to improve programs' performance and response time. In this article, we will discuss how concurrency is achieved in C++ and what are its benefits. Concurrency in C++ supports the concurrency was first added in C++11 to improve performance of the program and enable multitasking. The components such as thread, mutex, memory model, and various synchronization primitives were added as part of the concurrency support library. Although concurrency provides multitasking, it doesn't mean that tasks are executed simultaneously in different processing units. Instead, it works by task switching, doing some tasks for a small time and then moving to other tasks and then coming back again for the first task. It will keep doing it till both of the tasks are done. In different processing units. It does not mean. All right. We can achieve concurrency by using threads. Threads are basic unit of multitasking. The concurrent execution of tasks is done by creating multiple threads in a multi-threaded environment. The C++ provides a thread library for creating and managing threads. Multi-threading in C++. Errors and risks with concurrency. Concurrent multi-threading applications need to be carefully designed, as it is prone to many errors leading to undefined behavior. Deadlock refers to a situation where two or more threads are blocked forever, waiting for each other. Race conditions happens when two or more threads access shared data concurrently, leading to undefined behavior. Starvation is a condition, alright. Mutex and mutual exclusion locks are used to protect shared resources. Ensures that the only one thread accesses critical sections at a time. Condition variables, features and promises. Are used to synchronize task executions and available in thread task semaphores. Use cases, definitions, benefits of concurrency, performance, responsiveness. Ooh, that was something. I just want to look into this C7 paradigms. Function program paradigms, handouts, instructor, Jerry Kane. This is a cool guy. He explains stuff really well. All course material, handouts, memory, stack implementation, function call and return, factorial trace, thread, package, docs, concurrency examples. This is more concurrency, introduction to scheme. Yes. Oh, that's too bright, too bright. Threads, elanes, and pods. I see programmers won't be able to write in a Mac and PC. Debugging functions. Concurrency, thread package. Semaphores. Binary semaphore example. Canonical use of a semaphore is a lock associated with some resources that only semaphore patterns. This is a really good course. I need to do this. At some point, I would like to do this, but stuff is so wild these days. One watching now. This is a really good course. I need to do this. At some point, I would like to do this, but stuff is so wild these days. One watching now. This is a really good course. I need to do this. At some point, I would like to do this, but stuff is so wild these days. One watching now. This is a really good course. I need to do this. I think at some point at some point I like just reading and listening to lectures is okay, but I don't want to spend a lot of time just reading, because you have to be able to build stuff. Um, build your own, all of this network stack, operating system, 3D renderer, go build. I think it would be really cool to just read over those virtual machine homegrown. Scale, what to run, how to run, building a container. Oh, this is. Oh, yes, at some point I think I will start streaming building projects more than just reading. Because just reading, I can read endlessly and achieve nothing. But even if I build a Tetris game, this is still very cool. This is still some kind of achievement. You should follow me on Twitter, right? Fix English mistakes by proceeding to. Whoa, what? Language vertical movement. Oh, he has all of this set up for C++. Tetris tutorial. He has a really cool map. Has a really cool icon. JavaScript, build neural network, build a neural net from scratch, an introduction to convolutional neural networks, building an operating systems from 0 to 1. What? Bootstrap yourself to White House from scratch. You know, Stab, Wiki. Whoa, this is a lot of stuff going on. There is so much information, right? It's a hard work because there's so much information. and you need to know hack the virtual memory. What's that? Hack the VM. So strings and prod. Strings. Da, 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 da. Alright, let's wrap this live up because we're getting out of hands. We're searching everything, not just Golang. Alright, have a good night, whoever might be watching.